Our presenter today is Nihar Bihani, and today with us we also have a team of moderators who are going to be awesomely answering all of your questions, so send them over to them. Our team of moderators are George, Vijay, and Marco, and they're going to be engaging with you and answering any questions you have throughout the presentation. So Nihar, welcome. The floor is now yours.
Thank you. All right. Well, first of all, thank you very much for joining today's webinar. I'm really excited to talk to everyone, and we'll dive deep into a very specific topic today and talk about scaling your web applications for large volumes of traffic, and how you can use Amazon CloudFront to help you successfully do that. We will also talk a little bit about some of the best practices that in terms of CloudFront features that you can configure to help you scale for large amounts of traffic. So I start with a question, something to think about as you get started with this presentation. If you have an event, for instance, a launch announcement or a presentation, or if you've had surprise surge in traffic that you didn't expect, but you noticed that all of a sudden a large volume of users started to visit your application. And as a result of some of these large traffic spikes, if you have seen any outages or any performance issues for your application. So this is really the topic that I wanted to discuss and dive into today. And the way I've structured the presentation is to talk through three different things. First, talk about the different types of events, just from a general understanding of what I've gathered when I talk to customers, the types of events where they see large traffic spikes, and what are some of the causes of that. Second, talk about how Amazon CloudFront can help with scaling those applications. There are a number of features that are built into CloudFront that are made available to you as default capabilities to help with that scalability, and that's a big reason why many customers choose to use a CDN such as CloudFront. And then finally, also, even beyond just using CloudFront, what are some of the best practices and configurations that you can put in place to make sure that you are ready for any volume of traffic? So let's talk through the first topic here, understanding the different types of events. There are really three different types of large traffic spikes that I typically hear from customers about. The first one is anticipated search. This is the one that you do expect, and you also make effort to prepare for it the best you can. Some of the examples that I put up here, and there are many more, but launching a new product or a marketing promotion that may be short-lived, a special sale item that you may be putting up if you have any test, where you're broadcasting a live event, sporting event, music event, or if you have a partner that's conducting a load test and sending a large amount of traffic, and you're working closely with this partner, and you're aware that this traffic will be coming to your application. So in these types of scenarios, what you really should be thinking about is have you analyzed and predicted the traffic that you expect to your distribution, and have you set up all of the correct resources to make sure that you can scale when you do end up receiving this traffic. The second type is going viral. So this is one where you don't expect this traffic or you don't anticipate this traffic, but it's welcome traffic. It's really traffic that you do desire on your website. So let's say an article gets picked up by a major news outlet and you receive a large number of users visiting your site. Or Twitter, social media campaign that becomes viral again and has an impact that's larger than what you were expecting. So again, this is welcome traffic, but you still have to make sure that your application can scale for the volume of traffic. And the third is undesired traffic. So this is where you, again, don't expect this traffic, but it's also not welcome traffic. It's a denial of service attack to your application. It's bots or scrapers that increase the amount of traffic that they send to your application. So now one thing that customers often ask me is if we don't anticipate the traffic, how do we plan for something like that? How do we prepare and make sure that we're ready? And my response usually is, regardless of the type of traffic that you're receiving, preparation and preparing for that is really independent of what's causing that large traffic spike. When I talk to customers, one of the things that I've often found is some of the common failure points where the applications are not able to scale with that volume is either incorrect caching policy that the customers have configured or not configured, or an unscaled origin resource. Your data center or your application does not have the scaling mechanisms built in to automatically scale with traffic and handle that large amount of traffic. So let's look at this diagram, a very typical architecture where you have different types of clients, whether that's laptop, mobile devices, tablets, televisions, that are all communicating directly with your origin infrastructure. And you can see I've just thrown some numbers up there, but 25,000 RPS, let's assume, from every single client type, and 5,000 megabits per second. So that can cause a large amount of traffic coming to your website, to your application at the same time, especially if you're not ready to receive that traffic. And the impact of that? Well, the impact that causes is really high request rate. The request rate is high enough that it's happening faster than your application can scale to process every single one of those requests. And this is not just number of users we're talking about. We're also talking about every single asset that your origin infrastructure has to deliver. A typical web page, for instance, is constructed with many different assets. And so we're talking about every single image, JavaScript, or style sheet, and all the other assets that go into constructing that web page. They all count as a single request. And so you may end up seeing capacity, or your users may end up seeing capacity exceeded errors or 500 series errors when your application is not available. Similarly, high data transfer volume, if you're serving large objects, large bytes, videos, or bigger images are typical examples, or game downloads, that can saturate the network interfaces. So it's not so much about the servers anymore. It's the actual connectivity that your origin may have to the outside world. And that increases retransmits, there's more dropped connections, just drowns out the network. So really, for your customers, the impact of this is at best high latency, where things are slow, and at worst, some users don't get access to that content at all. So at this point, I'll pause for a few seconds. We have a poll question next, just trying to gauge if you have in the past experienced an outage or a performance issue due to a large traffic spike to your application, maybe one of the applications you work with right now or in a previous life, just trying to understand. So if you could take a few seconds and just vote, we'd just like to understand to what extent you've seen some of these issues that we just described. Great. All right, well, thank you so much. Just from what I'm seeing here in the poll results, almost 2/3 of the audience, 60 to 65%, is saying that yes, they have experienced an outage or a performance issue due to a large traffic spike. So that's very useful data, and hopefully with some of the information I have to share in the remaining slides, can help you prepare better for future events. So let's dive into our second topic. Let's talk about how CloudFront helps with some of these challenges. And in this part of the talk, we'll review things that CloudFront has built into the service already. You don't even need to configure. Just by the virtue of turning the service on, you get the benefit of these default features. But before we do that, let's do a level set. What is a CDN and why use one? So I think a lot of you are already familiar, but in case you're not, CDN is a content delivery network. It's really a distributed network of caching servers that are spread across the globe very close to where your clients are, where your customers are, and routes those users to the best location for each user, caches the content from your application so that when a user comes to one of these locations, they can download that content from a location near them very quickly. CDNs can also help accelerate dynamic content. So even when content isn't cached, a CDN can still help with network optimizations where it acts as a proxy and helps make the download of your dynamic personalized content faster. And finally, CDNs, they provide security, scalability, performance for your applications. Those are all some of the core tenets, benefits of using a CDN. So specifically, Amazon CloudFront, it's a global content delivery network. It's AWS's CDN. CloudFront was launched in November of 2008, so CloudFront has been around for close to 9 years. It's optimized for performance and scale, and we'll talk about some of these benefits in a little bit more detail. It has several built-in security features. It's fully self-service, like all other AWS services. You have full control over your configurations. You can use the API or the management console. CloudFront also offers a few real-time metrics and alarms that you can set. This is particularly useful when you get unexpected traffic, where you can set thresholds and alarms so that you get notified by AWS automatically when your application receives traffic over a certain threshold. And then CloudFront can be used for static, dynamic, as well as video delivery. So let's talk a little bit about the use cases that CloudFront supports. With the caching and acceleration technology that CloudFront has, we can deliver all types of content from static images to video. You see at the .com. You can also receive user input in the form of a post or a PUD, and then you can use SSL to secure the delivery. And you can do all of that by using a single CloudFront distribution. And whether you're using a custom origin or an origin inside of AWS, such as Amazon S3, an Elastic Load Balancer, you do not need to change any of your backend infrastructure. You create a CloudFront distribution and set what we call cache behaviors. And with cache behaviors, you define a URL path. So for instance, you see a couple of different URL paths in this diagram, start.php and start.jpg. And then based on the incoming request from the user, CloudFront can direct the request back to specific origin resource and get the data cache if the origin specifies caching, and then respond back to the user. So let's talk a little deeper about how CloudFront can help. So first, CloudFront, and I mentioned this briefly, CloudFront has a global content delivery network. It's a very large network that spans 48 different cities, 5 continents. We have 74 locations today, and also 11 regional edge caches that are akin to mid-tier locations that sit between the edge POPs and your origin resource. One of the ways in which we differ from, say, traditional CDNs, who may have thousands of edge locations, is we strategically have placed our POP locations globally. And because of the improved network connectivity and peering, a lot of the modern CDNs like CloudFront are just as effective in availability and performance and scalability without the need to have thousands and thousands of edge locations. So when we have, like I said, we have 74 different locations, and your users, your customers can be spread across the globe. The way CloudFront routes these users to the best edge location for them is using latency-based routing. So you'll see a couple of green arrows to the right side of this diagram. What I'm showing there is CloudFront is collecting latency measurements based on real users that visit Amazon.com and other Amazon properties. And based on the DNS resolver that these users are using, CloudFront is collecting latency measurements to each of our edge locations. And what we do after collecting this data is we create a routing engine map, and we put that at every single one of our edge locations. So to the left here, you see there's a user in Singapore. And this user does a DNS query that goes to their DNS resolver. And the DNS resolver gets a response back from the Tokyo Edge location. But the Tokyo Edge location knows that this user is actually in Singapore. And so it responds back with the IP address for our edge location in Singapore. So even though DNS is being responded over anycast from Tokyo, the actual user request will go to the Singapore edge location because this user is located in Singapore. So so we use latency-based routing, and this helps us distribute the load globally. So when you do have large traffic spike, when you have users distributed across the globe, it helps with scaling in that traffic is spread to the location that is best suited to serve a particular end user, closest to where those clients are. And so this helps distribute traffic to a number of different CloudFront locations versus all traffic ending without CloudFront ending at your origin. To add to that, CloudFront also supports EDNS client subnet, and this helps us route requests to the optimal edge location by looking at not just the DNS resolver's IP address, but the truncated version of the end user's IP address, which is added into the DNS request. So for instance, Google Public DNS or OpenDNS, they include this truncated IP address, specifically the first 3 octets of the end user in the DNS request. And we can use that information to very granularly target where the user is and send them to the best edge location. I briefly mentioned CloudFront has regional edge caches, which are akin to mid-tier locations. So today we have 11 regional edge caches spread across the globe. And the edge pops, one of those 74 pops, will go to a regional edge cache first before they go back to your origin resource. So these regional edge caches act as sort of a shield between the edge pops and your origin, and further help cache content close to where the viewers are. The regional edge caches are also larger than a typical edge location, so they can cache more content and for longer duration of time. This is a new default feature for CloudFront. So not only does it help improve performance, but it helps you scale your application without needing to scale your origin resources. So it can help keep more things in cache and respond to your viewers as more and more viewers request content without necessarily increasing the load that goes onto your origin resources. So here's a little diagram that describes previously all of our edge locations would go back to your origin directly. So that would be 74 locations going directly back to your origin. In the new default architecture, and the reason I mentioned default is because there's no additional charge for this feature. It's turned on for all customers that have non-S3 origins configured with their CloudFront distributions. And with this new architecture, you can see that the edge locations or a group of edge locations will first go to the regional edge cache before they go to the origin. So again, it lowers the load on your origin resources. And that's really important when you think about scaling, because as you get a lot more traffic than you might be anticipating to your application, you want a layer of defense, you want a network that can scale for you without you having to scale your origin resources. You could scale your origin resources, and that's the best practice. We'll talk about that. But again, that's expensive, that's more operational load for you, and that's where the CDNs come in to help scale without needing to really scale the origin. In addition to the large global network of physical locations, there's also a number of content optimizations that CloudFront has. So for instance, if a large number of users come to your application and they're asking for the exact same piece of content at the exact same time. So this could be an image, this could be a news article, this could be a live stream, for instance, where everyone's coming and asking for the same segment at the same time. CloudFront edge locations will collapse multiple users' requests for the exact same object and send fewer requests back to the origin. And if you're using a non-S3 origin, then the edge locations will first go to the regional edge cache, and the regional edge caches will do the exact same thing if there are multiple requests from multiple CloudFront pops arriving at a regional edge cache at the same time. The regional edge caches will collapse those further before they go to the origin. For content that when your origin is unavailable, CloudFront can also keep your application up and running by serving stale content. So that's another benefit of using CloudFront. This is something CloudFront does automatically. So if we cannot reach your origin resource, if we have that object in cache, CloudFront will serve it out and then try to reach your origin again to get the fresh copy of the content if it's expired. And for smooth streaming, we have video optimizations where we're prefetching automatically the subsequent segments for you. So if you're doing a large-scale event using smooth streaming, that's a benefit that you automatically get. So again, a number of content optimizations to offload as much of the scaling to the CDN network, to CloudFront's servers, and keep your origin servers lightweight. CloudFront also uses a number of network optimizations when connecting to your clients or to your customers. So TCP window scaling, for instance. And then also when CloudFront goes back to your origin resources, we keep persistent TCP connections to reduce the round trip time. Also, when you're using origins that are in AWS, so that would be Elastic Load Balancers, EC2 instances, Amazon S3, CloudFront goes over the Amazon Global Backbone Network. And this network is really designed to help reduce latency, minimum network path, so that responses come back faster, there are fewer drop connections back to your origin, which again helps minimize the amount of effort that your origin has to do in reestablishing a connection, particularly an SSL connection that can take several round trips. And finally, end-to-end security is something that also there's a number of security benefits that you get just by using CloudFront. So just by putting CloudFront in front of your application, in front of your origin resources, you don't have to give up on any of the security benefits to be able to scale for unexpected or expected traffic events. So you can do full end-to-end HTTPS delivery with SSL or TLS termination close to your viewers. So your viewers will terminate TLS at the edge location close to them, and then the edge location will have a new connection that is likely established and maintained back to your origin resource. CloudFront uses high security ciphers, perfect forward secrecy, which creates a new private key for each SSL session in the event that a private key for a session was discovered. It could be used only to decode that session and no other, past or future. So there's another benefit in terms of keeping your content secure. TCP fast open allows establishing TCP connections quickly with the client to minimize the time spent in establishing a connection. Session tickets help minimize the number of round trips involved in the SSL handshake process if the SSL connection is broken. And OCSP stapling is where CloudFront takes the onus of domain name resolution to locate the CA and validating the SSL certificate so the client doesn't have to and your origin doesn't have to either. And CloudFront does all of that heavy lifting for you. So again, I don't want to dive deep in all of these security features, but just wanted to get you a flavor of just by turning on CloudFront, you get a number of security benefits without even needing to configure anything. So another poll question, just trying to understand if you believe there are performance benefits in delivering dynamic content via CDN such as CloudFront. This is a question that I get often from customers, and I talked to a number of customers about this, so I wanted to see what you in the audience thought about this. So we'll just take a few seconds and allow you to respond. Great. All right, and just to share the results there, I'm seeing 95% of you saying yes. So that's great to hear because there are significant benefits in using CloudFront for delivering dynamic content, and some of that we already talked about in terms of the network optimizations, the persistent connections, and the TCP window sizing, and so forth. Okay, so let's dive into the third portion of the presentation, and let's talk about, beyond just using CloudFront, some of the features, some of the best practices that you can use to really get ready for expected or unexpected large traffic spikes to your application. So the first one, very, very basic, we'll start there, use caching. Use caching up and down the stack, not just CloudFront. Database access, we have Amazon Elasticache, the origin web tier, whether you can use, you have multiple options there, Squid, Varnish, Nginx. At the edge, that's Amazon CloudFront, and we're talking a lot about that today. And then browser. Browsers have a very small amount of cache as well, so we'll talk about how you can optimize and make sure that your content is also cached on the browser. I wanted to highlight, I put a link there, a new resource that we just launched earlier today. It's on the AWS website. It's aws.amazon.com/caching. Take a look at that. There's a number of good architecture diagrams and some best practices there as well. So I just want to call that out. So how does caching protect the server? So again, going back to the diagram, the architecture diagram we saw earlier, I have reduced the number of RPS now going to your origin by 10x, which is typically what you would see when you're caching with the CDN, that each of these clients can get their answers from the cache that is now sitting between the client and your origin 9 out of 10 times. And so now your origin really only needs to support 2,500 RPS per client type in this example. So that's a tremendous amount of benefit. And this is very realistic, even though these numbers are made up. This is something we see every day, where customers get tremendous amount of benefit just by, again, same idea, instead of the 5,000 megabits per second, if you remember from the diagram earlier, we're now seeing 500 megabits per second times the number of client types here, 4, that are going back to your origin resource. So tremendous benefit for, this will allow you to handle the network based on the network bandwidth capacity that you have available at your origin without needing to worry about rounding out your network. Let's talk briefly about browser caching. So max H is a cache control header where you specify the time to live, how long a cache or the browser should keep your object without expiring it or without evicting it. And most browsers have a small amount of cache. So if you set the right cache control headers, so in this case, I've given an example, cache control max H 3600. The 3600 number is in number of seconds. And so you can see that you're basically telling the browsers to cache your image or whatever it is that the client is downloading for that period of time. HTML5 application cache, it's essentially a way to make your application available even when the device is not connected to the internet, so offline. So that's another way to think about it if you're using HTML5 to design your application. Again, when you're configuring your cache control header correctly and caching things right at the browser doesn't even have to use the network and go to the CDN. And it really just helps eliminate all the network latency, and content is right there available for your users. CloudFront Edge caching. So for objects that are cacheable, images, things that don't change very frequently, you can set very high TTLs. And there are a couple of different cache control headers. One is max-h, and the other one is s-max-h. I run into customers often who may not understand exactly the difference, so I'll just walk you through that. The s-max-h is designed for shared caches. So this is really a cache or CDN like CloudFront. So you can specify how long CloudFront should cache your object versus max-h, how long the browser should keep the object in cache. So for instance, you don't really have a good way, or there isn't a way to invalidate or evict an object or force evict an object from a browser cache, but there is from a CDN cache because CloudFront provides you the API, or you can use the console to do that. So you may want to set a higher value for the S-max state, so you can keep an object in cache longer, and if you need to evict it or expire it, you can always use the invalidation API. And then set a low value for the max-edge so that browsers are frequently checking into the CDN to make sure that there isn't an updated version available. The second tip I have here is don't forward headers or query strings or cookies. So anytime you forward any of these back to your origin resource, CloudFront will consider that to be part of the cache key. So for the exact same image, if you're forwarding different query strings or different cookies that are coming in from the client, then CloudFront will fragment its cache, and there are more requests now going back to your origin because there are more cache misses. So the more you can minimize how many unique things you're sending back to the origin, the more number of hits you would see when a client makes a request for that image. These are things that you can configure in CloudFront, for example, the headers, the query strings, and the cookies. And so really use CloudFront defaults is as far as caching goes, so that you get the best cacheability and fewest requests going back to your origin resource. I wanted to switch over to show you the CloudFront console and see how you can set some of these cache behaviors. So if you go to the behavior step, so I'm in the AWS console right now, and I'm looking at one of the CloudFront distributions. It's just a sample CloudFront distribution. And if you go to behaviors, I have, and again, behaviors are, as I mentioned earlier, they are URL path patterns where you can set different configurations. So this is a default behavior. I only have one behavior in this particular distribution. But if I go to edit, you see here there are a number of different options that are available for forwarding headers. It says none improves caching, or you can have a whitelist of headers that you may want to forward to the origin. There are some tooltips available that can tell you more. Similarly for cookies, again, it says none improves caching, and that's the default, but you can also provide a whitelist of cookies. You can write the cookie names right here, and then those cookies and the values will be forwarded. Keep in mind, though, that then those cookies become part of the cache key for that object. Query string is the same way. You can do none, forward all, but cache based on the whitelist, or you can forward all and cache based on all. So there are a number of different options available to configure how you want to manage your cache within CloudFront, and you can do all of that using the API. So I'll just switch back to the slide deck. So let's move on to the second tip here. All right, so we'll cache everything possible. So not just use caching, but try to determine how much of your application you can really cache, including dynamic content. Some dynamic content can be cached for, even if it can be cached for a second, and if you're getting, for instance, tens of thousands of requests per second to your application, well, for those tens of thousands of requests that arrive in that 1 second, you're serving a cached version of your content. So unless it's completely personalized to each user, so some of the examples here, for instance, when you have, let's say you're presenting scores from a sporting event that's happening live. Now, that is really real-time and dynamic content because the score is changing, especially if you think about, for instance, a basketball game. The score is changing quite frequently. But for a few seconds, you can cache the score so that everyone that's visiting your application gets a cached version. And then once your TTL, your cache expires, let's say in 5 seconds, then CloudFront would go back to your origin and get the latest score. So CloudFront supports TTLs as low as 0 seconds. CloudFront also supports a no cache, no store, Essentially, CloudFront is compliant with the RFC as far as cache control headers. And so you can configure all of these depending on the needs for your application. Again, keep in mind, most content can be cached, even if it's for a few seconds. And the benefits, as I described, one, this really helps you scale because in that short period of time that you're caching something at the edge, CloudFront is not going back to your origin. And then also something we talked about earlier, if your origin, for whatever reason, becomes unavailable, CloudFront cannot reach it. CloudFront will continue to serve content that may have expired or is stale as long as it's in its cache. The third best practice here, use multiple cache behaviors. So, as we were looking in the console, cache behaviors are URL path patterns. And if you do need to forward any headers, if you do need to forward any cookies, you can restrict it only to a specific URL path so that it doesn't impact all of the other parts of your application that don't change based on those values, those headers or those cookies. For user agent specifically, CloudFront also translates the user agent header to a few different device types. So you can still do customization for these device types without actually forwarding the entire user agent header. I'm sure you've seen user agents. There is a million different variations in which the user agents arrive. And so CloudFront would consider, if you were forwarding the raw user agent back to your origin, CloudFront would consider every single one of those variations as unique. And so you'll have a million different versions of any given object in the cache. And let me show you quickly on the console again for the user agent header. So you can set the user agent header by configuring, let's say, a whitelist of headers. And then here you see different headers. So CloudFront is desktop viewer, is mobile viewer. So for instance, you can add these to the whitelist. And when you save, now CloudFront will start translating the user agent into one of these and start forwarding them back to your origin server. So your origin can still customize the response, but it's limited to these 4 variations versus, the millions of variations that may exist for the actual raw user agent header. All right, switch back to the slide deck. So optimizing the, so another is a network path. Talked earlier about how CloudFront already optimizes the network path using TCP window sizes or persistent connections. But there are also a couple of configurations we exposed for you. So the first one is using HTTP2. CloudFront supports HTTP2 between the edge locations and the clients. And so with that, with some of the benefits that you get as part of HTTP2, that's multiplexing, the header compression, stream priority, it really helps, particularly for mobile clients. It can help send data to those clients faster. Also, keep alive timeout. That's really a configuration between CloudFront and your origin resource. So it's configured to, by default, CloudFront uses a 5-second keep alive. But if your application is highly cacheable and there are fewer requests that CloudFront has to make back to your origin, then keeping a higher keep alive timeout, which you can configure all the way up to 60 seconds, may benefit where CloudFront doesn't have to reestablish a TCP connection with your origin when there is a cache miss at the edge. And again, reestablishing a TCP connection or TLS connection is just resource intensive on your origin. So these can just help minimize the amount of work your origin has to do. The fifth best practice, we talked about this earlier. Even if you're using CloudFront, you should still think about how you can scale your origin resource. So I have another diagram here. It's a little busy. Let me see if I can walk you through this. So, but the idea here is that using a number of different AWS resources that are already available, auto-scaling groups, elastic load balancing or application load balancers, EC2 instances on the back end, and then monitoring using Amazon CloudWatch, and scheduling the scaling for your events based on when the event is happening. These are all some of the best practices. There are many resources available on the AWS website, including white papers that you can review for scaling your origin resources. But this gives you, you'll see in box number 1, we have an auto-scaling group to have the desired capacity. And in 2A, you see a scale-out event occurs here. This event instructs the auto-scaling to launch an additional instance. And then in 2B, that launches the instance at a specific day and time. Box 3, you see the instance gets launched automatically and gets configured. In box 4 there, you see the instance is fully configured, auto-scaling attaches it to the auto-scaling group. And then number 5, a corresponding scale-in event that occurs. In 6, you see auto-scaling removes the instance, and then number 7, instance terminates. So again, I walked you through very quickly here, but the idea here is to use auto-scaling so that even when CloudFront is going back to your origin and the origins or resources need to scale, you can use AWS services to help scale your origin automatically. Number 6, let your origin do only the work it needs to do. So, certainly plan to scale your origin automatically, but the more you can offload from your origin, the better it is, so that you don't have to scale your origin and there are fewer risks with needing to scale your origin and let the CloudFront network handle that scale. So Amazon S3 for static assets. Amazon S3 is a highly scalable static object store. You can use that to have all of your static objects saved in Amazon S3. There's free data transfer from Amazon S3 to CloudFront. So anytime CloudFront goes to Amazon S3 to fetch an object, there's no data transfer charge there. Again, decreases the load on your web server because these requests from CloudFront are going to Amazon S3 versus going through your origin resource. And S3 is highly available and scalable. Another poll question here. I wanted to understand if you were aware or if you think that you can run custom configurations or custom compute at CloudFront locations. If you were aware of this, please say yes. Great. All right, we'll move ahead. About 2/3 of the participants said that they are aware. A third of you said that you were not. So let's talk about a little bit. This is a relatively new offering, a new feature for CloudFront, Lambda at the Edge. This is something that we announced at the most recent reInvent conference a few months ago. Lambda at the Edge allows you to run Lambda scripts at CloudFront locations, where you can write a custom script to customize or personalize the delivery of your content and have that run at CloudFront locations. You can configure different triggers or different events within CloudFront. And so you don't have any servers to manage. So again, less work for your origin to do. It scales automatically as the requests that arrive and the traffic that arrives to CloudFront scales. Globally distributed, so the compute and the personalization is happening very close to where the end users or where your customers are. And you never pay for idle capacity. It's based on number of requests. So let's want to dive a little bit deeper into Lambda at the Edge, since this is a new functionality that we announced. With Lambda at the Edge, you can configure 4 different triggers or events today. When the end user, you see here to the far left, makes a request, and then CloudFront responds back. Each of those can be an event that you can execute execute a custom Lambda script at. And then also if it's a cache miss, CloudFront sends a request to the origin, and you see the origin server to the far right, and the origin responds back. So those are the 4 different events. We'll walk through some use cases briefly here. You can, what a lot of customers are doing right now with Lambda Edge is they are doing content customization. So they are looking at the user's location or other properties of a particular user, what device that they're using, and they are then modifying, deleting, customizing the headers, for example. You can do A/B testing by, say, flipping a coin right at the edge to select version A or version B of your content without having to go back to the origin. Add content, you can rewrite URLs. You can hide your origin directory structure and make your URLs look cleaner. So those are some of the ways in which customers are customizing their content delivery using a Lambda script that runs at CloudFront location. Other set of use cases are visitor validation, so looking at whether the incoming request is a search engine bot and detecting that and then filtering that traffic potentially. Confirming a valid session, looking at a cookie, and confirming the legitimacy of a request. So again, wanted to give a flavor. A lot of the times when I talk to customers, they are using resources at their origin that sit in front of their application web servers, and those resources are the ones that are doing these kinds of customizations. You can now offload that, so you don't have to worry about scaling those resources. Let CloudFront and the Lambda scripts running on CloudFront locations scale automatically as more traffic arrives. Custom error pages. With custom error pages, you can, if your origin is unavailable, you can still make sure that your visitors are getting a customized branded response back from CloudFront. And you can have these error pages sit in Amazon S3 so that CloudFront can pull in this page from Amazon S3 and respond back to the user. So this is just sort of a last resort thing. If your origin is unavailable, CloudFront doesn't have the content in cache, you can use custom error pages to have your branded application available. Another quick poll, have you looked into securing your cloud infrastructure at the edge? Great, about half and half is the response there right now. Got a couple of quick things to talk about there so that we have some time for questions as well. One of the use cases, if you recall from the very beginning of the presentation, we talked about undesired and unexpected, unanticipated traffic. And that was really the bots, the scrapers. And there, CloudFront is integrated with AWS WAF, which is our web application firewall service. I have the URL there. You can learn, since we're short on time, I won't go too deep into this, but you can go and learn more if you're unfamiliar with the WAF product. And there are a number of pre-configured protections that are already available that you can use with CloudFront. There are 6 different protections against common attacks. So if you do have that unexpected traffic that arrives, having WAF integrated with CloudFront and set up and ready to go for HTTP flood protection, the scanner and probe protection that works by analyzing your web server access logs, looking for bad patterns. You can set thresholds, so there's documentation available on the AWS website. Take a look at that, and that's a good way to really mitigate that undesired traffic. Well, that's all I had. Just a couple of quick links here on how you can get started with Amazon CloudFront. There is a CloudFront free tier, so if you're new to CloudFront, you can use Amazon CloudFront at no cost for up to 50 gigabytes per month and 2 million HTTP or HTTPS requests. If you are using Amazon S3 already, look at our developer guide on how you can use CloudFront with Amazon S3 and set the right cache TTLs to make the most advantage or take the most advantage of CloudFront. For elasticity that they saw when proxying requests that were not cacheable via CloudFront, within Elastic Load Balancing backend. And the last call out is we do have monthly CloudFront office hours where you can speak with or ask questions of CloudFront product managers and CloudFront engineers. So the next one is just in a couple of days. If you're interested, please sign up at that link below. And we'll welcome any questions that you have. We make ourselves available every month. It's the last Thursday of every month. We make ourselves available to answer any questions that customers who are trying out CloudFront or even advanced users if they have any specific questions on CloudFront.